Hi guys, I hope we are doing good wherever we are. In this video, I want us to look at the sine and the cosine rule as already projected right here from our screen. We've done a lot already on trigonometry, but in this particular one, we're just going to talk particularly about the sine and the cosine rule. I believe this will be more like our conclusion for now in the topic of trigonometry. Okay, so we are already familiar with the terms such as solve the following triangle, and we all know that the word solve the triangle is used when we are required to find the values or the sides that are missing or are unknown in a given triangle. So many times we find that we can be given a right angled triangle. For such, we've been using trigonometric ratios, which has the sine, the cos, and the tan to find these. And sometimes we've been using the Pythagoras theorem to find the different solutions. However, when we're talking about the sine and cosine rule, we can use these basically to find the sides or the values of the non-right angled triangle. Okay, so how does this go about? So this is how we go about this one. So I want us first of all to consider the following triangle, which is triangle ABC. So we have our triangle there, and we can name this one A, B, and the other side there can be named C. So here what we are discussing is the sine rule. Before someone gets confused, we're talking about the sine rule. So now we've got triangle ABC given like that. So how then does this thing work about? How do we find the sides of triangle ABC? So now before we can go further, we know that the opposite of B simply becomes B, the opposite of A becomes A, and the opposite of C is usually C. So this is what we usually have, something like that. So now nextly we're going to cut the given triangle into two like that. So when we do that, we now have let me just do it nicely so that it's at least neat. Yeah, so when we cut our triangle like that, this becomes the height or the altitude of the triangle. So when we do that, we see that now we have two triangles, which is this one, and the sides will become A, B, and C, and that one becoming B, this one simply becoming the altitude, which is the height. And on the other side we also have another, which is that one, and that will be B, that will be A, that will still be C, C, small c, and the top we've got the capital C like that. Okay, sorry, this is not supposed to be B, they are supposed to be C. Yes, that will be a small c down there. Now, because we know that C represents the whole distance from A to B, so meaning here we definitely have to use a different value and not C, because because C represents the whole value. So we can even use X or Y. So we'll just pick Y, and there also we'll use Y, assuming that it was a triangle, assuming that AY and YB are just the same, and especially that they've been cut at the same side. So now what do we do after having cut here? So now we come up with some important values from this moment, and we are going to use sine to find the value of A first in triangle ACY. So we're going to look at triangle ACY, and on the other side we're going to look at triangle YCB. So firstly, we are saying we need to find the height or the altitude of this triangle. So we're going to use sine sine theta, what is our theta? Our theta is A. Sine theta is equal to opposite is H over our hypotenuse is simply B. So on the same side, we do exactly just what we did even on the other side. And this is going to become sine theta, our theta is B, is equal to the opposite, which is A, over the H, and the hypotenuse is A, like that. So now when we multiply B with sine A, it simply gives us sine A is equal to H. And same on the other side, we have A sine B is equal to H. So now here we've seen that we have found two values which are equivalent to one variable, which is H. So it simply means that at this point we can pick any of the two and substitute one of the two to come up with something that is simple and straightforward. So we're saying A sine B is equal to H. But since we know that here we had found this also to be the value of H, we can substitute that where H is here. So instead of saying H, we substitute the value of H gotten on the other side, and this is going to become B sine A. Okay, so having now reached here, what do we say? So we are going to reduce this one further. So how do we reduce this one further? It is by dividing both sides with a denominator that is common. We could either use AB, or we can use sine B sine A. So to make our work easier, we'll pick sine A sine B, sine A sine B. Why sine A sine B? It is because sine A sine B is common. It can be divided into both sides. So even the other side, we say sine A sine B. So having reached here, we divide sine B with sine B, and this side we divide sine A with sine A, and what we remain with is becomes A over sine A is equal to B over sine B. And if we continue on picking other sides, we'll actually find out that these ratios are just one and the same. They give us the same value. So we're saying sine A over sine A is equal to B over sine B, which is also, if we are to continue, equal to C over sine C. And this one is what is known as the sine rule. So now the sine rule can be used for a number of things. We can use it to solve a number of different other triangles. We can use this one to solve a lot of other triangles, like we have said. But basically this is the sine rule. So we can use it to find the sides of any type of a triangle that is not a right angled triangle. So now let's now look at the following. So this rule, which is the sine rule, the question is where can it be applied? Where can the sine rule be applied? Where can we apply the sine rule? Number one side and any two angles are initially given. So when one side and any two angles are given, we can apply the sine rule. And secondly, where else can this sine rule be applied? Just a minute, let me just clarify that one. Where else? We can also apply the sine rule where two sides and an angle is given. So when two sides and an angle are given, let me even just correct my English there, it's supposed to be. So when we are saying when two sides are given and an angle is also given, we can definitely apply the sine rule. When one side is given and any two other angles are also given, the sine rule can also be used. It can be applied. Okay, so now let's look at an example before we proceed to the cosine rule. Okay, so now we can look at something like this, and we are saying we've got R, we've got Q, and we've got P, and automatically that will become our small r, and our P here will be equal to 36.5, and our small q there will be equal to 29.6, and these are all in millimeter. So there are times that units are not given. In a place where units have not been given, we shouldn't worry, because if units are not given, simply just don't apply any units, just leave them just like that. So we've got our angle, which is 36 degrees here. So applying the sine rule here, how does this become, or how do we go this about? So this becomes 29.6 over sine 36, and this will be equal to 36.5 over sine p. Now, what have we done here? We've simply applied the sine rule. Remember, we had A is equal over sine A is equal to B over sine B. So this is just exactly what we've just done when it came to there. So we've just applied. So we had sine theta, which was equal to that sine theta, which was sine 36, and we had another sine which we do not know, which is sine r, which is this angle which has been given there. So now we are calculating for sine r first, and getting what we have there. So this will become sine p is equal to 36.5 sine 36 degrees, and this is divided by 29.6, and this now eventually gives us our answer, which is 0.7248. So now that becomes our answer. So now, trying to take us slightly backwards where we started from, I believe we mentioned this at one point or another, where we have a triangle such as this one, and remember, in finding our h, let's see, so this becomes C, that becomes A, and that becomes B. So remember, in finding our h, we had to pick sine A, which is equal to opposite over hypotenuse, and on the other side again we had sine B, which was equal to h over A. So now we had our value of h here giving us A sine B, and on the other side we had H also giving us this is B sine A. So what do we see here? So we see that picking this particular side and that particular side, picking the sine of this particular angle, multiplying it with that particular side, it gives us the height, it gives us the altitude, and just the same, which also what we have also on the other side, it still gives us the same altitude. So we could use these two to find the altitude. So meaning from here we could come up with the formula of area of a triangle, since we know that the area of a triangle is a half base multiplied by height. So now this will become half, the base is C, multiplied by height, which is A sine B, or if you want, you could choose the other height, which will still at the end of the day give you the same value, half multiplied by C multiplied by B sine A. So here now it will turn into half BC sine A. So this could be used to find the area of that triangle, or we could also have half AC sine B. This can also give us the area of a triangle. So this is where they get the area of a triangle, which is in this format. So I'll just end here for now, and if there are any questions, you can simply send them to me and we can see how we can respond to those. So for the sine rule, this is how we go about it, and any other questions can be found using the sine rule. So basically this lesson was actually meant to prove and show us how we can come up with the sine rule.